All right, I think we're live. Hello and welcome into my channel. I am Professor L, and I just want to say happy Thursday to everyone. So I am going to be working on my board, and I've decided to continue the problem that I didn't finish it yesterday. I worked on it a little bit more. I didn't really have a whole lot of time. I haven't solved it yet, but I think that I'm closer to solving it. And yeah, we'll just see how it goes. After the stream yesterday, because I don't accept defeat very well, I went ahead and asked Google Chat how to solve this problem. And I was actually surprised that even though I didn't solve it the same way as the bot did, I actually got the right answer for the missing side. And I used half angles, and it used I don't remember what it used. Some kind of weird variation of, I still don't understand the formula they used, but I think it has to do with like laws of cosines, and then um, yeah, anyway, differences and sums of squares. But I do think I have enough of the algebra to go ahead and try to solve for the other two sides. So that's what we'll be doing. So hopefully it won't take too long. And so hope everyone's doing well. And I'm not going to erase everything here because I'm just going to erase, because I'm still working on this problem, I'll go ahead and leave the problem up, and then I'll just be real careful about what I erase. I have a better sketch of the triangle, and so I want to go ahead and the accurate sketch is probably for me the majority of solving most of these application problems. Getting a very good idea of what the problem is, and I am a visual person, and so a picture for me is worth 1,000 words. And I hope I have those half angle identities handy, because I think I'm going to go ahead and scrap this. Yeah, okay. So what we'll do is we'll erase all of this, because I start getting my head gets cluttered if there's too much in front of me. I believe that simplicity is best, and I prefer, just by nature, I tend to be a minimalist. So I prefer things simple, and so if the problem becomes too complicated, you split it up into smaller problems, solve them individually, and then you can add them together. And so that's taken me all the way through some of my advanced math classes. So let's go ahead and make a list, and then I want to draw the triangle out of this textbook, because this textbook is the one that gave me this problem. And it's not the triangle for this problem, but I really liked how he had it organized. Very similar to how I had it organized. B, A, C. And then I'm going to try to draw the circle inside of this. And you just want it to touch all the sides. It's tangent to all three sides here. And I really don't want to muddy this up too much, but I do know that the radius is 6.8. So we have an angle, and I went ahead and chose beta. And we'll just try to stay organized. And it's saying find all side lengths. So we'll go ahead and label them A, little b, and little c. Okay. And then I did make a list of the formulas that I thought I would use. I realized that I do need to get more organized, and this problem, it didn't look initially, first glance for me, it did not look like it would be as hard to solve as it is, but it was. So I want to do next is I want to go ahead and list all of the formulas, and I'm going to try to do it and see if I can save some room here. Okay, so we need, let's see, the area and expressed in as the semi perimeter and the in radius. So radius times S, where R is in radius and S is the semi perimeter. And by definition, the semi perimeter is half the distance around the triangle. So the perimeter would be all of the sides added together. The semi perimeter would just be that divided by 2. So we need my tangent. So I went ahead and put that on here, I guess, the tangent that I need. All right, so we need tangent of beta over 2 equals R divided by S minus B. And I solved that, but we're going to do it again. And then we need the perimeter. This is a tangent half angle. And then we have P equals A plus B plus C. And we also need the area expressed as 2 side lengths. So we have A equals 1/2, and then A's area, so we'll list that, but A times C times sine beta. And there's 3 different ones of this one, and there's also 3 of these. And what it is, it's depending on, it all depends on basically what angle that is known. And since I only know one angle, I chose it to be beta just to stay organized. But you could have chose it to be alpha or gamma, whatever angle that you want, which A, B, or C, it's up to you. So I chose beta, and that's the one I'm going to use. And so then it's expressed in a ratio of these other 2 side lengths. So it's all proportions, basically ratios. All right. And then the other one is the quadratic. And I went ahead and let them give me this one, but we'll put that one up at the end because we're going to use that after we get all this, if we get far as I want to. All right, so I'm going to go ahead and list my values here and try to stay organized. So my in radius, here, let me put this up here real quick. A equals area of triangle. So I missed that value. This is a tangent half angle, and this is the area as expressed by a portion of the side lengths. So we have R equals 6.8, and we have A equals 496. And we'll leave the units off, and we'll put them in again at the end because units are important. But we're trying to simplify and keep this as simple as possible to not overcomplicate it. So we'll just remember that they're feet, remember that they're units, and then we won't have to just put them on every time. Okay, and my lack of sleep is showing now. Okay, 26 minutes. And I did figure that to be a decimal. However, I erased it, and I think it was 58.2. 58.43. Okay. So we will first go ahead and calculate. Let me see how this steps here. All right. First, we're going to use this one right here and go ahead and calculate this value because the semi-perimeter is not known. And we are going to use the perimeter formula, so we want to know the perimeter. And so what I can do is I can find out what the semi-perimeter is and multiply it by 2 and know the perimeter. So step 1, we'll go ahead and list this. Step 1, find semi-perimeter. And we have A equals RS. So A is 496. So we're going to say 496 equals 6.8, which is the radius, times S. Divide off the 6.8. And you have S equals 496 divided by 6.8. And I'm getting 72.94. And I guess we'll just leave it in the hundredths for now. All right. So I need to start boxing these values because I need them. So I'll just box this one. I have the semi-perimeter, and then I can also calculate the perimeter. So we'll go ahead and do that real quick. And I'll say step 2, find perimeter. And so I'm just going to say it's going to be the perimeter equals 2S. So the perimeter equals 72, approximately 145.9, or we'll say 882. So approximately 145.88. And we'll box that one as well. And then we're going to now find the, we will use this formula to find AC. So that's step 2. Find the product AC. So find the product of 2 sides with step 3. So we're going to use this one. A equals 1/2 AC times the sine of beta. And see what we know. We know area and we know beta. So let's solve it for AC first. So first by multiplying both sides by 2. So that's going to be 2A equals 2 cancel AC sine beta. And then we're going to divide off the sine beta. And we're going to get AC, the product of 2 sides, is going to equal 2A sine beta, 2A over sine beta. At this point, we'll plug in because we know A, and we also can calculate sine beta. So we're going to say AC equal 2 times 496 divided by the sine of, and we'll go ahead and, we can go ahead and use the rounded 58.43. If it was an official problem and I was having to plug in the solution to an interface that was online and it was going to be picky about syntax, I would probably use exact values and pay attention to rounding a little bit closer, but we're just having fun practicing a method. So we'll go ahead and try and keep it simple. So we'll go ahead and say the distance AC, or the distances, the product of those two distances is this value, 2 times 496 divided by the sine of 58.43. And I'm getting 1,164, and I'll say 0.32. And we're going to go ahead and we need that value for layer, so we're going to box it. All right, step 4. So what do I need to do next? So I know AC. Oh yeah, I have to use tangent beta and find A. And I did this yesterday, and so I'm pretty confident. I was not confident at all because it was just like, I've never done this before, and it's been a while since I've done the trig, so I'm not real fresh with it. All right. So anyway, step 4. Solve. So we're going to be able to solve for, wait a second, did I write that down wrong? All right, hang on a second, I don't trust it. Making sure, it's not, it's B. I thought I got that wrong. This is B, so I don't want to mess up. Okay. So we're going to use this half angle identity for tangent of beta, and we're going to find little b. So we were able to find this side, and we did that yesterday, and we called it A. That's why I want to recalculate it. It's just because depending on how you have your diagram set up. Yesterday, my triangle, I said alpha was the one I know, and I changed it. So it's a little minor difference. Anyway, so we're going to solve for the missing side. Solve for side opposite angle beta. I will not be lazy. I'll better write it out. That is known. And we use tangent. So say tangent of beta over 2 equals R over S minus B. And remember, we solved for B yesterday, so we're going to go ahead and do that again. And I want to do it, do I want to put the values in before or after? I'm tired enough where it's making me indecisive. Let's go ahead and plug in the values, because we should have everything known besides B. Oh, I'm just going back and forth on it. I'll tell you what, since we did this one here, we'll do this one the same. So we'll go ahead and solve this for B. And we got to multiply the quantity, whatever's in the denominator, in the numerator, making the quantity 1. So we're going to multiply both sides. Actually, I want to rewrite it. Write that in a new step. Tangent of beta over 2 times S minus B equals R over S minus B times S minus B. Those will cancel. And I have R. And I'm not done yet because I need to solve for B. So I have tangent of beta over 2 times S. And all I'm doing is taking this tangent and I'm distributing it across both terms. So I've got tangent beta over 2 times S minus tan. Oh, we'll put the S out front. That's better. It's like something looks weird. So we'll say minus beta, or sorry, little b times tangent beta over 2. And that's going to equal R. Now, what I need to do is I need to get, I'm isolating the term that has B in it. So I'm going to do that by subtracting this entire quantity here from both sides. And it's positive here, it's going to pop up negative on the other side. So we'll subtract, so we'll say minus S tan beta over 2 minus beta tan, oh, sorry, plus S tan beta over 2 minus B tan beta over 2 equal R minus S tan beta over 2. These are going to cancel. And I've got negative B tan beta over 2 equals R minus S tan beta over 2. And then finally, we got to multiply everything by a negative 1. So I'm going to get B. Oh, yeah, easier. Hang on. Listen, we'll just, instead of doing that, we're going to divide it off. It'll be all in one step. So this right here is negative 1 times B times tan beta. Since these are all multiplied, what I'm solving for B, then I need to divide off the negative 1 and the tan beta over 2. So I can do that as long as I do it to both sides. So I end up getting negative tan beta over 2 over here on this side, and I have solved for B. B equals R minus S tan beta over 2 divided by negative tan beta over 2. Interesting. All right. And so we can calculate that. We can plug in. We know R, we know S, and we also know tangent of beta over 2. So, so we got B equals, let's move it up here a little bit. It's got room. We got little b equals R, which was 6.8 minus S. What was S? I don't remember. 72.94. Oh, I already ran out of room. Let me scoot it over. Okay. Let's try it one more time. All right, so we've got B equals 6.8 minus 72.94 times the tangent of 58.43 divided by 2. And that is divided by negative tan of of 58.43 divided by 2. And then I got it all written out. All I need to do now is just find the approximation in the calculator. So see how I want to do this. I'll just say, let's figure out what 58.43 divided by 2 is. And we'll put this on our list. Beta over 2. 58.43 is 29.222 approximately degrees. All right. Okay, so we'll go ahead and say 6.8 minus 72.94 tangent 29.22. And the top I'm just going to approximate it, it's fine. Negative 33.9898 divided by, and then negative 1029.215. I'm getting negative 55.9224. Close enough. Wait, there's no way. Hang on a second. 33. I did something wrong. I know I did. There's got to be a syntax because there's no way. If I divide those. Oh, it's point. Oh, goodness. I am suffering from lack of sleep. So hopefully I sleep good tonight. 0.55. I was like, wait a minute. That scared me. Okay. I'll just back it up a bit. Negative 0.55922. Okay, that's closer. So I got 60.78. So that's approximately 60.8. Using half angles. All right, so let's go ahead and make a list. We've got the little b here. All right, and we've got 2 more sides to find. So step 5, we've got to find a place to put that. I have got to find I've calculated a plus b already. So now, okay, a plus b, how did I do it? Okay, so I put in, looks like I used the semi-perimeter formula. Let's see. So we have the semi-perimeter equals S equals A plus, it's the perimeter divided by 2. And we used a different formula earlier to calculate it here. But we can use this to find A plus B because we know wait, A plus C rather, because we know B. So multiply both sides by 2. And I at 2s equals, those cancel. You get A plus B plus C. And B was 60.8. So you'll say, we'll just do it here. 2s. And let me go ahead and plug in what s is since I know it. We'll say 2 times 72.94 equals, and then I solve for B. So it's A plus 60.8 plus C. And then 2 times 72.4. That's the total perimeter. I thought I'd already calculated that. I did. It's 145. Okay. So I've got 145. Let me calculate it. 188 equals 60.8 plus A plus C. And then we're going to subtract off the 60.8. I'm getting 85 over here, 8508. And that equals A plus C. All right. So we have A plus C and we have A times C. A plus C and A times C. All right, so A plus C and A times C. What are we going to do next? We're going to solve for the other two sides. So we know the sum of the sides. All right, so what this is telling me is that here, A, side A, which is this side, and this side here. Sorry, A and C, it's this side, these two sides. So you got this side and this side. And we know this side is 60.8. We solved for that. Put that in there, 60.8. But what we know is we know the sum of these two sides, and we know the product of the two sides. So there's a sum to product rule. And I don't know how to, let me just think about it. Let me go ahead and ask sum to product for the last step. Sum to product. And if it doesn't, oh, this is, I guess I was wrong about the sum to product. Okay, so that is if you know two angles. I don't know two angles, so I can't use that. Difference of squares, sum of squares. How can I figure out there's a sum of squares and product of two squares? And I said that was 8508. So It's a variation of the quadratic formula. Where can I put this? I did so well organizing, but I ran out of room. Dang it. Okay, so what we're gonna do is, so we have this thing going on. So we have, there's an identity, and I didn't put it, I'll put it up here. So you've got a squared plus b squared. Where is it? Let's mess it up. Last night when I was working on it, I came across this identity. This might help me. All right, it says b, and this is the difference of squares and the sum of squares. So you got b minus c squared equals b plus, wait, no, it's a. What do you think a? A and c. Because we already know b, so that's not going to do us any good. So we use a and c, and it's a plus c squared minus 4ac. So this identity right here might help us, because we already know these values. I'm not sure, but we'll figure it out. So this right here, let's see if I'm able to solve one of these other sides. And see if I can sneak some of this in here. A minus c. See. So you have a minus c squared. And we have a plus c is 8505. So that equals 8505 minus 4 times 1164. Ran out of room. So let's sneak it in here in the next line here. This. Okay, see if I can put this in here. I'm running out of room. So we had a minus c squared equals, and it's a plus c, which is 8508. And now 8508 minus 4 times a times c, which is 1164. 0.32. So I can figure that out. All right. Okay, negative 4 times 1164.32. It's negative. Wait a second. Is that minus 4ac or is it plus? Yeah, it's minus. Okay, let me think about this for a second. So -4, it's going to be a negative number. Maybe. All right, 85.08 minus 4 times 27. Right, 2 times A. Okay. Well, all right, 1164.32. Okay, that's a really large, ugly number. So it's saying AC squared, and you can't, oh, because the distance, I think. So you got A minus C squared equals oh wait, we have, where is that perimeter formula? Here. We have this thing right here, so I'm trying to use this one instead. Because this one's proven to be too challenging. So there's got to be another way to do it. All right, so if we have, we have A, B, and C here, and no B. So we can say that, let's say B, hang on, Q equals A plus B plus C. I know B is 60.8. So I can say P equals A plus 60.8 plus C. So I can say A plus C equals P minus 60.8. And I also know that that is equal to 8508. 85.08. Okay, that's getting me somewhere. So I have this thing. Perimeter here minus 60, or P minus C rather, is equal to 8508. So A plus C is equal to P minus B. And I have AB. So I'm going to have to use that ugly quadratic they gave me. See how this works out. So this says x squared minus P minus C plus AB equal 0. And this was for step 5. That was 4. So step 5 was to find the other two sides. So I can use this formula here. So we'll just say x squared minus P minus C or P minus B, hang on, that's P minus B. We don't even need to know it's 60.8. We just need to know it's, yeah, we do, 60.8. Okay, so where's that at? It's 85.05, so X minus 8505 plus A times B. Not that one, that's AC. It's 1164. There's the X there. Plus AB. Sorry, AC. 1164.32. All right. So we have this quadratic. So you'll say A equal 1, B equal negative 85.05, and C equal 1164.32. And I have my calculator has the quadratic formula programmed into it, so I can cheat, I guess, and ask the program. Ah, this one's a new one. I gotta get my own calculator. It's got every program that known. It's got them all in here. So, goodness, my calculator's got a strip in it. I hope it's just the battery going bad. What occurred? Okay, it is a fix. All right, A plus 1. Program 4. Here. A is 1. B was B. Negative 85.05. And C was 1164.32. And do I want an exact or an approximate? It's decimals, so it's just going to give you an approximate anyway, I think. So we'll just do an approximate. And it says real root 17.4. So X equals 17.14. 17.14. And 67.903. So here's your other angles. So your other sides, but this is very unsatisfying because I don't know which one is which. How do I know what side length A is since I had to use the quadratic to split these two up? So the other two side lengths of the triangle, I guess since we don't know the angles, then we can just guess, since it doesn't matter. If it was the angles were known, it would be another story. But we've got A equal, we'll just say it's the smaller one, 17.14, we'll say 17.1. And then we've got C equals to, what does it say, 67.9? So we'll say that's 60, yeah, we'll leave it 67.9. So here's your side links. Very unsatisfying problem that took me 2 days and 2 hours, and I actually have done. I don't want to mess this formula up, so I'll say, okay. Alright. You gotta be careful how you exit those programs on those calculators, because it'll ruin your whole your program. At least I could. All right, so thank goodness that we were able to solve this problem. It was very challenging for me, and if you thought it was challenging too, go ahead and let me know. I want to be able to definitely engage with my audience. I know I don't have a very large one right now, but yeah, I will be approachable, and I would rather promote the group study of the math. It's definitely teamwork, very important again. And so, again, I'm going to go ahead and stop there. That was almost an hour, and we got it done. It was, I'm a little worn out now. And I guess we can go ahead and call it good. Yeah, day 2. And again, I'm so glad we got this done. All right, very good. Well, I'll go ahead and conclude my live stream for tonight. And I just want to say, if you watched my video, thank you so much for watching. And I hope it wasn't too boring. You know, I realize that math it's not the most exciting subject for most, but it is exciting for me, and it's very challenging. As you can see, I was mentally challenged by this problem, but I made it through somehow, and yeah, so I feel good about it. Yeah, and I just feel like it's great that I'm getting the practice, and I need to learn how to get in less stiff in front of the camera, because I want everyone to be able to see me for who I am, my personality. And so it's hard because I'm just like panic because the camera's there, but I feel like I am relaxing a little bit more, in which that is a win. And yeah, so I'll stop rambling on, and yeah, I'll go ahead and say goodbye for now, and I will see you all next time. All right.